right, in this lesson, we're going to learn how to find the possibilities for the zeros of a function just by doing a little bit of simple math. If you look at a function and want to decide without graphing it and without factoring it what the possibilities are for where it could cross the x-axis, which again, remember, is just called the zeros, where it crosses the x-axis. You can do a simple ratio just to figure out what those possibilities are to kind of narrow it down. And the way we do that is we use this rational zero theorem, which just states that if you take the factors of the constant and the factors of the lead coefficient, which in this case, number one, that lead coefficient is just 1. If you take and put those into a ratio, then you can figure out what the possibilities are. So, for example, if we know that the factors of 1 are just positive and negative 1, the factors of 21 are positive and negative 1, and positive and negative 21, positive and negative 3, and positive and negative 7. So those are your options. You have to account for the fact that there could be a negative factor thrown in there. So that's why we account with it by saying positive or negative 7, positive or negative 21. So you're going to want to do that with each of these. Once you have that set up, the ratios are simply the constant over the factors of the constant, I should say, the factors of the constant over top of the factors of the lead coefficient. All right, so that sounds probably a little bit confusing. Once I start doing it, it should make more sense. So one option is to take this first factor for 21, positive 1, and put it over, positive or negative 1 rather, and put it over the lead coefficient factor, which is positive or negative 1. Another option would be positive or negative 3 over positive or negative 1. All right, and so on and so forth down the line. You always put the factors of the constant in the numerator, the factors of the lead coefficient in the denominator. Now this looks a little strange. I'm writing it out like this just to show you what's kind of the idea. But if we were to go in and then just simplify this down, I mean, all of this is being divided by 1. And so we would just simplify it like this, okay? If we have 1 in that denominator, we really don't have to write it out. So here is the list of possible zeros. It doesn't mean these are all zeros of this function that's listed out in number 1, but these are the possibilities. We've narrowed it down to where this can potentially cross the x-axis, and that's all they've asked us to do in this problem. So we'll do the same thing on number 2. We're going to look at the factors of 30 and put them over the factors of 2. So the factors of our constant over the factors of our lead coefficient. So the factors of 30 are going to be positive or negative 1, positive or negative 30, plus or minus 2. All right, so there, I think we got all the factors, the possibilities for 30, and then the possibilities for 2 are plus or minus 1 and plus or minus 2. So those are your two factors there. So now we have two factors that need to be accounted for in the denominator, so it's going to make our possibilities our possibilities list a little bit longer. I'm going to start with putting all of the factors for the constant over this plus or minus 1 first, because remember, the ratio says put the factors of the constant over the factors of the lead coefficient. Okay, so that's don't do it the reverse. We always want the constant in the numerator. So plus or minus 1, I'm getting that from right here, and then plus or minus 2 from, plus or minus 1 down here from the factors of 2. So there's one option. Now you can see that this can just be reduced down to plus or minus 1, just like in that first problem. So I'm going to go ahead and erase that out of the denominator, and just when I write them out, that way I don't have to reduce in the end. So same thing here, plus or minus 2. It really is going to be over plus or minus 1, but I'm not going to write it in because it's going to save me some time having to go back through and rewrite. So all of these would be over 1, and when reduced down, we would just have these. Now we have to go back in and pull out the ones that are going to be over 2. So now I'm going to go back. I'm going to say, go back to the beginning. My first my first factor for the constant 30 is plus or minus 1. Now I'm going to put everything over this possibility of, of 2 being in the denominator. I'm going to save us a little bit of work here as well. This is technically how this should look, plus or minus 1 over plus or minus 2, but when I go in to reduce it, what I would do instead is I would have it look like this, with the plus or minus sign out next to the fraction. All right, that would be the reduced form of it. So I'm just going to go ahead and write them in that manner. We would go to plus or minus 2. Now this plus or minus 2 is going to be over this plus or minus 2, which when we reduce it is going to give us plus or minus 1. We already have that on our list, so we don't need to write it again. All right, but then I'm going to come over here, plus or minus 3 over that plus or minus 2 would give me this. So I need to write that. That's a new one. Plus or minus 10 over plus or minus 2 here. If I reduce that, I'm going to get plus or minus 5. That's a new one. I don't have that one on my list either. But I should have that. I should actually have that on my list for 30. I did miss that. So stuck right in here should have been plus or minus 5 and plus or minus 6. All right, I'm going to go here, plus or minus 15 over 2. Right, that's a new one. We don't have that on our list yet. And then plus or minus 30 over plus or minus 2. We do have that on our list. That reduces down to plus or minus 15, which we see right here. All right, so the only one I was really missing was that plus or minus 6. I'm going to go ahead and erase this out so we only have it written in one time. And there are the possibilities. There's a lot more for this problem, because we have, we have 30, which is has more factors to begin with, and then we've got a lead coefficient of 2, which is going to give us more factors in the denominator that we have to account for. So again, these are possibilities. They are not all going to be zeros. These are just possibilities that allow us to narrow it down and use it in another type of problem later. All right, so in 5 now, they're asking us to actually find all of the real zeros. In 1 and 2, they asked us to find the possibilities, knowing that all of those possibilities are not actually going to be zeros, they're not going to be x-intercepts. But in 5, they want us to narrow it down to the possibilities and then actually find the real zeros. So we're going to start by narrowing it down. We're going to do that again by using that rational zero theorem we just used, finding factors of 8 and factors of the lead coefficient 1 and putting them in a ratio. 8 factors are going to be plus minus 1, plus minus 8, plus minus 2, and plus minus 4. Okay, so there's our factors for 8, and then our factors for 1 are, of course, plus or minus 1. So when I write out the possibilities, the possible rational zeros, I'm putting the numerator over the denominator. So plus minus, I'm putting the constant factors over the lead coefficient factors. So plus minus 1 over plus minus 1 is going to reduce to plus minus 1. All right, same thing here, plus minus 2 over plus minus 1. We're just going to call it plus minus 2. And so hopefully you're kind of catching on. When the lead coefficient is 1, the possible rationals are just the factors of that constant. So these are the possibilities right here. We're going to pick one now, because now they actually asked us to really find the zeros. So we're going to try one. And I'm going to start with 1. Okay, I'm going to start with this positive 1 here, and what I'm going to do now is use synthetic division. All right, so I'm going to set up my box. I'm going to divide by 1, and I'm coming in here to my polynomial, and I'm pulling the coefficients out in order, making sure that they haven't skipped over a term, or that it's making sure it's in standard form. Pull this 1 down, remind myself I'm going to multiply going around the corner. All right, and then right here we see we have a remainder of 0. If you remember back from a couple sections ago, if we get a remainder of 0 here, then it means that 1 is a factor. This is one of the zeros. All right, so I can use that to write out the binomial that I'm getting this from x minus 1 right here. Okay, so I'm writing out the binomial that is a factor of this function right here, this polynomial, and then I'm coming from here and I'm saying my coefficient on my x squared is going to be 1. I'm saying x squared because I've got to go 1 degree down from the lead coefficient, or the lead term on the actual polynomial. Because in the end, if I were to go back and remultiply, I want x times x squared to give me x cubed, which is what I have over here as my lead term. And then I'm going to go down in order from there. Okay, now from here, I have to make sure that that trinomial is factored completely. So I'm going to look at factors of -8 that add to -2. That is factorable. X minus 4 and x plus 2. All right, so now I've got all 3 binomials. I know from here, in order to actually solve for x, to actually solve for the x-intercept, I'm going to set each of those binomials equal to 0. And of course, you don't have to do this step right here. That this is one of those steps that we've talked about before. If you can do it, the algebra without, physically setting each of those equal to 0 on your piece of paper, that is okay. So these are your 3 zeros. So we went from finding the possibilities for those zeros, which is up here. This is where we started. We knew all of them were not zeros. There's no way this function is crossing the x-axis that many times, but we knew they were the possibilities. I picked 1 because it's the easiest to do synthetic division with. Picked 1 to do synthetic division with. I came out with a 0 here. Now, if I hadn't gotten a 0 as a remainder, I would have had to have gone back up and picked another number and tried it until I got 1 that actually is a 0. Once I had 1, then I write it out as the binomial with the polynomial, the trinomial that it's multiplied by, and then make sure it's factored completely, set those binomials equal to 0, and solve for your x's. So we'll do the same thing again on number 6. We're going to find our possibilities first. I'm going to kind of shortcut this a little bit and just write them out for us here. These are our possibilities. I'm getting that from, fortunately, our lead coefficient is 1, so that makes this a lot easier. And then I have factors of my constant, which 4, 1 and 4, and then 2 and 2. I account for both the positive and the negative signs, and because all of those are going to be set over that lead coefficient factor of 1, we really don't have to do a whole lot of, we can just kind of reduce in our heads there. So these are the possibilities. I'm going to do the same thing because it's easy to do synthetic division with 1, and 1 is one of the possibilities. I'm going to set up my half rectangle for synthetic division using x of 1 right here. Okay, pull down this first term, the first coefficient, and remind myself I'm going to multiply going around the corner. All right, and again, fortunately, first try, that's not always going to happen, but first try we get a 0 remainder, which tells us that 1 is a factor. So I know that one of the binomial would be x minus 1. And then I'm going to look at my degree. My highest degree is 3 in this polynomial, so I know this the first term in my trinomial is going to be an x squared plus 5x plus 4. And then I've got to look here and say, is this completely this trinomial completely factored, meaning can I find factors of 4 that add to 5? And the answer is yes. I can break that up into x plus 4 times x plus 1. All right, and so from here I'm going to set each of those equal to 0. And I'll get x of positive and negative 1. I'm doing both the first and the last one, and an x of negative 4. So these are the 3 zeros. This is where this graph crosses the x-axis out of these 6 possibilities that we came up with right here. Now, when we have a graph like in number 11, we can find the possibilities for the rational zeros and with that rational zero theorem, and then we can narrow it down by looking at the graph. So for example, if we were to find the factors of our constant 9, that would be these 3 right here, and then the factors of our lead coefficient 4 are these right here. Okay, and this is going to give us a good amount of possibilities because there are so many factors. So we would end up with plus or minus 1, plus or minus 3, plus or minus 9. That's, of course, setting all 3 of these over plus or minus 1 and reducing, which I'm just not showing you all that algebra. Then I'm going to take all of them and put them over the 2. So we'd end up with plus or minus 1 half, plus or minus 3 halves, plus or minus 9 halves. And then, of course, we've got to do the same thing again, all over plus or minus 4. Okay, so we get all of those as possibilities. Of course, we don't want to have to check them all out with synthetic division. So if we have a graph, we can actually take those possibilities and come over to the graph and see if any of them sort of match up. So we can see on the graph here that it looks as if our x-intercept might be at 3. It looks here like it might be at 1 half, and then down here it looks like it might be at negative 1.5. So I can come over here and look on my list and say, yes, positive 3 is a possibility according to my list. Positive 1 half is a possibility, and negative 3 halves is a possibility. So the graph and the list check out. So what that allows us to do then is to pick one of these that checks out both on the list and on the graph and try it out with synthetic division. So I'm not going to try 1 here, even though in the previous 2 problems I tried 1 because it's easiest to do. I'm going to start with 3 because it does look like 3 is probably one of the zeros. All right, so I'm going to set up for synthetic division. And it does check out. We've got a 0 as a remainder, and so this tells me that 3 is one of the one of the zeros. So I'm going to use it to write out my binomial and then my trinomial. Right now, from here we have a trinomial with a lead coefficient that is not 1. So we're going to have to do a little extra work to factor this one. I'm going to take the 4 and the negative 3 and multiply them together. That will give me negative 12. I'm looking for factors of negative 12 that add to positive 4. And that would be 6 and negative 2. So I'm just going to go through my steps now. I'm going to disregard this x minus 3 just for a moment so that we don't have a lot of just extra numbers floating around. All right, so this just goes back a couple of chapters where I'm rewriting 4x here as a factor, as a product, sum now of 6x and negative 2x. Okay, I'm going to group them off and finish out factoring by grouping. All right, my binomials match, So I'm going to factor the binomial out that's common to both of them. And then I'm going to need to remember to pull that x minus 3 down here to the bottom. Now I have it factored completely. I can set each of these equal to 0. And I'll end up with x of 3, x of 1/2, and x of negative 3/2. And if I look at this and compare it to my list up here, these all check out. Positive 3 was definitely an option. Positive 1/2 was an option, and so was negative 3/2. So that all checks out together. All right, now I want to skip over to number 14 and find all the real zeros of this function. So again, we'll start with our possibilities, but that requires factors of 8 over factors of 2. So plus or minus 1, 2, 4, and 8. And those are going to be set over plus or minus 1 and plus or minus 2. So that's going to give us possibilities of these 4, each of those over 1. And then those again set over 2. Plus or minus 2 over plus or minus 2 would just give us plus or minus 1, so I'm not going to rewrite that one. Plus or minus 4 over plus or minus 2 would give us plus or minus 2. I already have that one written. And then plus or minus 8 over plus or minus 2 would give us plus or minus 4 again. So this is actually my complete list right here for possibilities. All right, I have plus or minus 1 on my list, so I'm going to go ahead and start with it simply because it is easy. Okay, and setting up for synthetic division. All right, and I can see really quickly here that this is not going to give me 0. So this is 1 is not a factor. Okay, this is not a factor of this function. So now I've got to move on to the next one. Sometimes you can kind of you can try the negative and it might work, but I can sort of see here a lot of times if the negative version of whatever you used would work, this right here would have been like positive 8 instead of negative 8. And so sometimes you can kind of tell in some cases, not always. I'm just going to go ahead and move on to number 2 and see if positive 2 is an option and set that up again. All right, and I'm just doing the same steps. I'm just double checking, seeing if this one works. All right, and again, I can see this is not going to give me 0 down here, so this one is not a possibility either. All right, I'm going to go ahead and try the negative version on this too, just to see. So it's really kind of at this point when you're doing synthetic division, it's a little bit trial and error. Actually, this is supposed to be positive 18 right here. So I've got a positive 4. This could be negative 8. Okay, so this one does work because I end up with a 0 for my remainder. So negative 2 is my factor. So again, remember these are always written in as differences. So it's x minus a negative 2, okay, which is really x plus 2. And then I'm going to rewrite in that trinomial. And then I've got to double check and see if this can be factored. So I'm going to do that. I have an x of 2 instead of, I'm sorry, an a of 2 instead of 1. So I'm going to do lead coefficient times constant to give me 8. Factors of 8 that add to negative 9 would be negative 8 and negative 1. So I'm going to have, I'm going to rewrite this. I'm going to ignore the x plus 2 for now. Rewrite negative 9x as negative 8x. Actually, I think I'm probably going to need it the other way. I'm going to need my negative x here first and then my negative 8x. Because remember, when you group off now, I want to make sure that I can pull out factors that are common. So now I have to continue my factoring by grouping. Yeah, and this one works. This works because I end up with 2x minus 1 in both of those binomials, which is what I would need. And then I can't forget to drop that original binomial down, set all of them equal to 0. I get x equals negative 2. X equals a positive 1/2 and x equals a positive 4. Okay, so here's what I'm getting algebraically. If I go back up and compare it to my list, I can see that each of these numbers is on my list of possibilities, so they check out with that.